Welcome to Conceptual Cambridge. Today we are going to cover part 2 of the functions video and we are going to go over the transformation of functions. So let's begin. So what are inverse functions? Basically they just reverse what the original function did. So let me give you an example. For example, let me take the function f of x is equal to 3x minus 1. So let's discuss what is happening to our input value, which is basically x. So it is being multiplied by 3 and minus 1, 1 is being subtracted from it. So now what the inverse function is going to do is add 1 and divide by 3. So let me do that. So for example, adding 1 and dividing by 3. This is what the original function is going to look like. I'm going to show you an easier method in the next slide. For now, let's focus on this. So what is the condition for first let's discuss the notation. So the notation is f minus 1 of x. This is the notation for the inverse functions. So now let's move on to the condition. So the condition is that the function should be a one-to-one function. Now let me explain why. So for example, let's consider a function f of x. Now what I can say is I can assign it some value. First let me erase everything, 1 minute. Now what I can say is that I will assign some values to a function. So for example, I can say f of 1 is equal to 2, and I can also say f of 5 is equal to 2. I'm taking a function that is not one to one. This is a function which is many to one, as many x values 1 and 5 are having the same output value, which is 2. So now let's say the inverse function f minus 1 of x is equal to h of x. So let's say that. So for example, as I showed before, what the inverse does is undoes what the original function did. So basically it goes back to the input values. So if I was to put in h of 2, it should give me the answers 1 and 5. But this is not a function according to a definition. So this is why we cannot have inverse of functions which are not one to one. So now let's move on. So these two things are going to be the main things that are going to be asked a lot in your papers. The domain of the inverse function is equal to the range of the original function. So for example, if the domain is x greater than 1, the range will be y. We can also write it as f of x greater than 1. Same with this, I can write f minus 1 of x less than 1, for example, and the domain could be x less than 1. So these two things are the main things. Also, I forgot to mention that the function and the inverse function are just reflections in the line y is equal to x. For example, let me take something like this over here. Then y is equal to x will be a line like this. And let's say I have a function which goes like this. So now the inverse of this function will just be a reflection like this. This is also one of the main things to remember. So now let's move on. So here, as you can see, I've written down a better method to find the inverse. So first of all, rewriting the function and replacing f of x with y. As you can see, I've done that here. Then step 2, replace x and y variables with one another. As you can see, for this step you don't have to do this. If you don't want to, you can replace at the end also. For example, what I can do is keep it as y is equal to 3x minus 1 and then solve it, bring minus 1 over to that side, it becomes y plus 1 and then divided by 3. So y plus 1 divided by 3 gives me x, and then I can replace the variables. So as you can see, this is an easier method to find the inverse. This is an algebraical method which is very easy. You can also do a horizontal line test to see if a function has an inverse. It basically just shows if a function is a one-to-one function. For example, let me give you an example. So as you can see, for example, I have a function like this. This is the exponent and this is the y. So if I was to draw a horizontal line like this, as you can see, it's covering 2 points. So this will not be considered a one-to-one function, hence this will not have an inverse. However, if you were to take it from this point, the horizontal line was from this point, then it will be a one-to-one function. What this means is if you limit the domain and range of this function, it can be considered a one-to-one function. This will also be very important when solving the past papers. Now let's move on. So now let's see graphing functions. So for example, let me take a function f of x is equal to x plus 1. Let me draw out a table for it. So as you can see, all I have done is inputted the x values and found the y values from this function. You can do this for any set of values, and let me draw a graph. So as you can see, I drew a graph over here. I have also shown a better method in my previous videos. I will link that in the description. Now let's move on to the transformation of graphs. So as you can see here, we have transformation of graphs, and we are going to go over the 4 very basic rules. So now, as you can see, first rule is this: y is equal to f of x plus a, which basically means what is happening to it, y plus a. So what this means is that the translation is going to be, the graph is going to move upwards as the a is positive. And these two things, basically we write x upwards and y downwards. These explain the translations of this. If it was negative, this would be minus a. And now for the second rule, what is happening to it, y is equal to f into x minus a. So there is translation in the x direction. It will be positive. I will explain this in the next slide. As you can see here, even the fourth rule for the x, it is a bit tricky as it is not very direct, but for y it is very direct. Whatever is happening to the function, basically that is your answer. So now let's move on, and I will explain to you what is happening to x and why are the translations like that. Alright. So as you can see, I've taken a function over here and drew its table and also its graph. So as you can see, f of x is equal to x plus 1. Now let's give it a translation like this. So we have f of x minus 1. So now let's see, by the rules, what should happen is that the translation should be 1 and 0. This is what the translation should be. But as you can see, it says minus 1 over here. So now to explain that, let me draw its table. As you can see, I drew its table and its graph also. So now let's see what is happening. You need to describe the graph whenever you're going to explain these questions. So as you can see, let's take a coordinate 0 and 1. Let's take this coordinate. So what is happening to this coordinate? As you can see, 0 1 is becoming 1 2 1. Every same y value is being moved 1 right. So every x value is being moved 1 ahead. This is basically what is happening to the graph, and this is what you are going to explain. So as you can see here, I've taken another example. I have two functions over here and I drew them out. So by the rules, the translation of this function to be 3 and 0. Now let's take a coordinate, for example 0 and 1, right? So now let's see where is the 1 now in the second graph. So as you can see here, 1 is at 3, it has moved 3 right. So now you can describe this graph as translation by vector 3 and 0. Now let me explain the multiplication rule 1. So now I've taken two functions again and I'm going to explain them. So the first function is f of x is equal to x plus 1 and the second function is 2x plus 1. So by the rules, the translation should be the sketch factor 1 over 2. This should be sketch factor 1 over 2 in x direction. So now let's take coordinates again to explain why this is happening. So let's take some different coordinates, 2 and 3 for example, this coordinate. And in the second graph, let's see where 3 lies. So the 3 lies at this 1 and 3. So for the first one we have 2 and 3, and for the second graph we have 1 and 3. Now let's describe what is happening. So as you can see, every x value is being halved. What you can say is 1 over 2 into 2 is equal to 1. This is basically what's going on. Alright, this is the end of functions. Next we are going to cover chapter 3, which is coordinate geometry.